Order of operation with rational numbers is really no different than order of operation with any other number. But there is one thing that sometimes gets overlooked and that has to be kept in mind. If you have a fraction for a numerator and a fraction or an expression involving fractions for a denominator, as we have here, you have to imagine that there are actually brackets around the numerator and brackets around the denominator. In other words, the expression on the bottom here, 3/5 plus 2/3, that has to be evaluated first. You can't do any kind of division, let's say 5/2 divided by 3/5, before you do the addition on the bottom. So let's see what we could do with this. Now, one approach would be, again, strictly follow the order of operations and do evaluate the brackets first. Well, the numerator is already simplified as far as you can go, but the denominator can be simplified, and we can turn that into a couple of fractions with a common denominator. The common denominator would be 15, so the first one becomes 9/15, and the second one becomes 10/15. We still have the 5/2 on the top. We don't need to write the brackets in as long as we understand that effectively there are brackets around the numerator and the denominator. So here we have 5/2 all over 19/15. And now we can do what we've done in the previous example, which is the previous lesson, which is turn this into a product. So we have 5/2 times the reciprocal of 19/15, which is 15/19. And there's no, we can't do any simplification here. So the 5 times 15 becomes 75, and the 2 times 19 becomes 38. So we end up with 75/38. Now, there is a slightly different approach, and this becomes quite useful when we get into fractions that involve any kind of algebra. And that is to try to clear the fractions. To do that, what we're going to do is pick a number that represents the lowest common multiple of all of the denominators of the smaller fractions. So in other words, we're looking for the lowest common multiple of 2, 5, and 3. Those are the three denominators, and the lowest common multiple of those is 30. And then what we're going to do is we're going to multiply the fraction on the top by 30 and the fraction or the sum of fractions on the bottom by 30. All right, now here we really do need to put the brackets in to make that clear. And what happens? Well, we've picked 30 because we know it's going to cancel with all of the denominators, by definition. So we know that the 30 and the 2 have a common factor, leaving us with 15. So we end up with 5 times 15 on the top. And on the bottom, we have 30 times the first fraction. And again, the 5 has a common factor with the 30, leaving us with a 6. So that's 3 times 6. Plus, and when we multiply the 30 by the 2/3, the 3 is a common factor, and that leaves us with a 2 times 10. And so what does this result in? So we end up with 5 times 15, which is 75 on the top. That's the same as we had before. On the bottom, we have 18 plus 20, and that's 38. So we end up with exactly the same result. And notice that we didn't have to add the two fractions on the bottom, right? We essentially multiplied them by an integer that turned the fractions into integers, and then we were just adding integers. I mean, really, there's not a whole lot of difference between these two approaches, but it's just a nice, useful technique to have, and later on when we get into algebraic fractions, it'll become very, very useful. Let's just take a look at one more example, maybe a little bit more complicated example, one where we have to pay attention to the order of operations a little bit more. Let's say we have 3/5 plus 2/3 all over 1 plus, and then in brackets, a half plus 2/3 squared. So order of operations tells us that the brackets have to be evaluated before the exponents, and then before anything else we do. So let's do that. We can do a little bit more. while we do this, we can sort of prepare to do the addition on the top. We're going to have a common denominator of 15, so we can turn that into 9 over 15 plus 10 over 15. On the bottom, we're going to have 1 plus, and then what do we have in the brackets? Well, we can create a common denominator of 6, so we have 3/6 plus 4/6, and all that's going to be squared. So we can actually go ahead and do the addition on the top, right? We're almost treating these as like separate problems, so we're not violating the order of operations here. We have 19 over 15 on the top. On the bottom, we still have the 1 plus 7 over 6 squared. All right, so we end up with a 19 over 15 still on the top. And 1 plus 7 over 6 squared is 49 over 36. All right, so to add 1 to that, we're going to have to turn 1 into an equivalent fraction, which is 36 over 36. And we're going to be adding that to 49 over 36 on the bottom. On the top, we still have 19 over 15. And so the bottom becomes 36 plus 49 is 85. And that's over 36. Now finally we just have a fraction over a fraction. We can turn this into a product. So we have 19 over 15 times the reciprocal of 85 over 36, which is 36 over 85. Now the numbers are certainly big enough here that we definitely don't want to just blindly multiply. We want to look for whatever canceling we can do. Unfortunately, there's not a lot we can do, but there is a common factor of 3 with the 15 and the 36. So when we take out a 3 from the 15, we're left with a 5. And we take out a 3 from the 36, we're left with a 12. So now on the top we have 19 times 12, which is 228, over 5 times 85, which is 425. So, you know, the numerator and denominator are a bit bigger than the ones we've seen before, but really all the way along we were just doing things that we had seen before and that we're comfortable with.